Let's talk about the force comparisons info and template page. This choice will only be available for some of the case studies, the ones that involve an injury to, let's say, a bone, like a fracture or a break or something. So if you click on this template, it'll take you to Canva, and you'll have force comparisons. You don't have to use this template. This is just something to help you get started. What you do need to include though is at least 10 comparisons, and you need to include the body parts that are associated with your case study. Also, go ahead and leave the femur there. It has everything you need for that one, including the work shown in this next slide. So to break your collarbone is estimated to take between 7 and 25 pounds. If you convert those into newtons, that's between 31 and 111 newtons of force. From this YouTube video right here, it takes about 4,000 newtons of force to break a femur. If there are sites that provide a range of needed forces, I would suggest to find either 2 or 3 sources with different possible ranges and taking the average of them for the force needed to break the bone. So take a few minutes and watch that video. On that video, there's a list of sources that they used. You can explore them to get more results or search up specific things yourself. When I looked through some of the sites that they had on there, some of them were no longer visible, but see if you could find anything that's useful there. The sources that you find for the force to break each body part could be measured in pounds. However, your force comparison chart should also be measured in newtons. To convert pounds to newtons, use the following conversion equation below. So for pounds to kilograms, we're given that 1 pound is approximately 0.453592 kilograms. Force equals mass times acceleration. So the mass, we have pounds, and we're going to change it into kilograms because the mass needs to be measured in kilograms. And then we have the acceleration due to gravity, 9.81 meters per second squared. Let's go ahead and go over the template example. So we're going to arrange these from least amount of force needed to break to most amount of force needed to break. We want to include the name of the object, such as femur. We want to have how many pounds it takes to break it on average, which was 899 pounds. The amount of newtons needed to break it, which is 4,000. And then the area, the approximate area of the front of that object. You can use rectangles to approximate this. For this, I have the bone right here and I drew a rectangle. We look at the given length. So if we find a resource, it says the average femur is about 18.9 inches. We're going to change those inches and convert them into meters, which is 0.48. From there, we're going to set up a proportion. We have the length of the picture, which is 9 centimeters. I just measured it on the screen. And then we have the width of the picture is about 1 centimeter. And then the length of the average femur was 0.48 meters. And then what we're solving for is the width of the average femur. So we could cross multiply. We have 9x equals 0.48. Divide each side by 9. We get approximately x is 0.053. So that's where we get this from. We're going to multiply the length times the width from there, and we get the 0.0256 meters squared. From there, we're going to find the pressure. The formula for pressure is P equals force divided by area. Well, the force was 4,000, and the area we calculated was at 0.0256. Plug that into the calculator, and you get about 156,250 pascals. So in addition to having your slide with all the force comparisons, the pictures, the information, the labels, you need to show some work on each of those 10 things. One of them is already done for you, the femur. And then you'll just do the work on 9 others. And also just draw that rectangle around your pictures. You want to use a ruler for this to help you with deciding the length and the width. So let's go over the rubric for this. For data collection, your data is collected for the force needed to break the 10 objects, including the femur that was in the example and the body parts that are relevant to your case study. For the calculations, work is shown to calculate pounds, newtons, area of the front of the object in meters, and pressure in pascals. Now, you'll have at least one of these without calculating anything, and you'll cite that with your citations at the end of your presentation. Now, for the presentation, you'll have your Canvas slides embedded into your final presentation. There are 10 objects, including a femur and body parts relevant to your case study, with the amounts to break them listed in pounds, newtons, and pressure. The area of the front of each object is also labeled. Each object contains an image to represent the object. And then also the used sources are cited at the end of your presentation. I look forward to seeing some very creative looking force comparison charts.